Hello again. Now let's start our lesson on 8.6, which is vectors and parametric equations. We're going to be talking about parallel and perpendicular vectors, more from yesterday. And then we're also going to be talking about a new kind of line, which is called a parametric equation. Parametric equations give us a linear representation for x and a linear representation for y. In other words, how is this changing along the horizontal axis, and then how is it changing along the vertical axis? And we do this in relation to time. So given this equation right there, x equals 3 plus 2t and y equals negative 4 plus 5t, we see that x is a function of t and y is a function of t. A good way to think about these is first starting out with graphing them. So I'm going to graph this line. My table didn't show up like it did for you guys, so I don't have enough room. I'll probably have to do it off to the side. But let's just put in a t equals 0 to begin. Let me redraw here. So let's put t equals 0 in. Well, when we do that, we're going to have 3 plus 2 times 0, so just 3. And then for the y, we're going to have negative 4 plus 5 times 0, so just negative 4. What that has generated for us is at time 0, we have the coordinate point 3, negative 4. All right, let's try putting in a t equals 1. And we've generated the point 5, 1. I'm going to give you a second to put in a few more values. I'd like you to do all the way up to t equals 4 and check back. So hit pause now. All right, welcome back. I filled out my table. Hopefully you filled out yours. And then I wrote everything as coordinate points just to kind of, help us visualize what's going on here. Now, I'm going to graph it. Also, it's good to mention before I graph, or actually as I graph, that the x values, they follow everything we know about a regular linear equation. They have a starting point of 3, that would be my intercept, and then they have us going up by every 2, so 3, and then 5, and then 7, and 9, and that's because its slope is 2. Same thing with the y's. You have a starting point, an intercept of negative 4, and then you go up incrementally by 5s, just like a regular linear equation would do. The coordinates that we get, 3, negative 4, 5, 1, 7, 6, 9, 11, blah, 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 they also give us a linear equation. So 3, negative 4 is approximately there, 5, 1, 7, I'm obviously really fudging this, 7, 6, and 11, and you'll see we have a linear equation in its own right. The horizontal axis is growing in 3 plus 2t, and in the y direction, we're growing negative 4 plus 5t. So it's just another way of making a line, and actually, if you know a lot about parametrics, you can make any equation do this, and or any picture do this. Really, the reason why it's nice is because if you want to draw something that's not a function, you have that ability to do that, and we'll talk more about how that works later. Okay, so let's think about what the slope of this line is. So when we find regular slopes of any other line, we might look at 2 points and then talk about the rise over run. So what is the rise over run here? Well, it looks like we have risen from negative 4 up to 1, so that's a 5, and we have run from 3 to 5, and that's a 2. So it looks like our slope is 5 halves. Take a look right here in the equation. The slope of the x line was 2, and the slope of the y line was 5. Interesting that we end up with a slope that corresponds to that. All right, what is the initial point of the vector? So you want to just look right here, not of the vector, excuse me, of the parametric. When we put in t equals 0, that's the starting point. Now, here's the thing, we are dealing with a line, so we obviously know this keeps going on forever, but it's a great way of thinking about when t equals 0, you have 3 and negative 4. That comes from right there in the equation. When we put 0 in for t, the slopes went completely away, and we ended up with 3, negative 4. I'm going to continue the rest of this lesson in another video because I don't want this one to get too long. So we're going to start on part C. That's your basics of a parametric for now.